What if alien life already exists? And we've been looking right at it without recognizing it. Most of us imagine aliens as green little beings, walking, breathing, and thinking a bit like us. But what if real alien life looks nothing like Earth? Nothing like biology as we know it? Today we'll explore the cutting-edge science and research into the possibility of life beyond carbon. Part 1. Our assumptions about life. When scientists search for aliens, they usually start by looking for planets like Earth. Why? Because our planet is the only example of life we know. We depend on water, carbon, and DNA. So naturally, our telescopes search for rocky planets in the habitable zone, where liquid water could exist. But here's the problem. If life can form in ways completely different from ours, we might be ignoring the vast majority of living worlds. What if alien life doesn't drink water, breathe oxygen, or even use carbon at all? Part 2. The case for carbon life. Carbon is special. It can form 4 strong chemical bonds, making it incredibly flexible. It's the Lego block of biology, able to build proteins, DNA, and cell membranes. That's why life on Earth is carbon-based. But carbon isn't the only element capable of complex chemistry, and that's where things get really interesting. Part 3. Silicon, the popular alternative. Some scientists think silicon could be the backbone of alien biology. Silicon sits right below carbon on the periodic table, meaning it shares similar chemical properties. It can form long chains and complex molecules, just like carbon. In fact, science fiction writers have long imagined silicon-based aliens, perhaps crystal-like beings, living in environments too extreme for us. NASA researchers have even suggested that in high-temperature worlds, silicon chemistry could dominate. Imagine aliens not made of flesh and blood, but shimmering crystal creatures walking across volcanic landscapes. Part 4. Life without DNA. But what if aliens don't use DNA at all? Here on Earth, DNA and RNA store instructions for life. But scientists have created xenonucleic acids, synthetic molecules that can also carry genetic information. This shows that DNA isn't the only game in town. Life elsewhere could use completely different biochemistry to store its blueprints. If aliens don't use DNA, even if we brought one into a lab, would we even recognize it as alive? Part 5. The search for weird life. Astrobiologists call this idea weird life. Not little green men, but organisms so different from us they might not even register on our instruments. NASA's Astrobiology Institute has actually funded projects specifically to explore weird life. For example, in 2010, a controversial study claimed bacteria in California's Mono Lake could incorporate arsenic instead of phosphorus into their DNA. The claim was debated, but it opened the door. Maybe Earth itself already hides alien-like chemistry. Part 6. Moons as alien worlds. When we think of alien life, we imagine planets. But some of the best candidates are actually moons. Europa, a moon of Jupiter, hides a global ocean beneath its icy crust. Enceladus, orbiting Saturn, shoots water geysers into space. Both could host life very different from ours. NASA's upcoming Europa Clipper mission will dive into this mystery, searching for chemical fingerprints of alien biology. If we find even a single microbe under the ice of Europa, it would change science forever. Part 7. Life in extreme conditions. Here's the twist. Earth itself already shows us how weird life can be. Microbes called extremophiles live in boiling acid pools, deep ocean vents, and even inside nuclear reactors. Tardigrades, tiny water bears, can survive being frozen, boiled, starved, and blasted into space. If life can survive in such insane conditions here, why not out there? Part 8. Beyond chemistry. Energy beings? Some researchers go even further. They suggest alien life might not be biological at all. Could plasma clouds or even electromagnetic patterns qualify as living systems? If intelligence is about processing information, maybe alien minds exist in forms we can't touch, like conscious networks of particles. What if we've already met aliens, not in UFOs, but in the very fabric of physics itself. Part 9. The Fermi Paradox. Of course, if life is possible in so many ways, we run into a mystery: the Fermi Paradox. If the universe is full of life, where is everyone? One possibility is simple: we don't recognize them. They could be living right now in forms we mistake for geology, chemistry, or even just noise in our instruments. Part 10. The future of alien research. Right now, telescopes like the James Webb Space Telescope are scanning exoplanets for biosignatures, chemical fingerprints, and atmospheres that might suggest life. But if aliens use different chemistry, we may need to completely rethink how we look for them. We often take Earth's recipe for life for granted. But imagine a world where ammonia, methane, or even liquid nitrogen replaces water as the solvent for biology. On Saturn's moon, Titan, rivers and lakes of liquid methane cover the surface. NASA scientists have speculated that if life exists there, it may swim not in water, but in liquid hydrocarbons. Instead of oily slicks being poisonous, they might be the cradle of life. What if Titan already holds alien life, but when we send probes, we dismiss it as just chemistry? Aliens on Earth? One of the most intriguing ideas is that alien life might already be here, hidden in plain sight. Astrobiologists have proposed the shadow biosphere hypothesis, the possibility that a second form of life, unrelated to our DNA-based biology, could exist on Earth right now. We may have missed it because our scientific tools are designed to look for Earth-like chemistry. If life used a different set of molecules, we'd simply filter it out as noise. Hook. Imagine scientists discover alien life not by looking into space, but by looking under a microscope in their own lab. The tools we're using to find life. The James Webb Space Telescope is already scanning exoplanet atmospheres for hints of gases like oxygen, methane, and carbon dioxide. These are considered biosignatures, gases that on Earth are produced by life. But what if alien biology creates gases we don't expect? We could scan right past signs of life because we're not looking for the right fingerprints. To prepare for this, researchers are building massive chemical libraries, trying to catalog every possible molecule that life could produce, not just the ones we know from Earth. Historic UFO research and science beyond biology, there's also been renewed interest in unidentified aerial phenomena. While most of these cases likely have natural or human-made explanations, they push scientists to broaden the search. The Pentagon's UAP Task Force and Harvard's Galileo Project are trying to bring hard science to a subject once dismissed as fringe. Even if most sightings aren't evidence of alien visitors, the attention highlights a truth. We know shockingly little about what may share the universe with us. The scale of the universe. There are an estimated 200 billion stars in our galaxy alone, and at least 2 trillion galaxies in the observable universe. Even if only a fraction of stars host planets, and only a fraction of those host life, the numbers become staggering. To say that Earth is the only home to life begins to sound not just unlikely, but almost impossible. With numbers this vast, the question shifts. It's no longer, are we alone? It's, how crowded is the universe? Alien intelligence. If life is common, then intelligent life may also be out there. The famous Drake equation was created to estimate how many civilizations might exist in our galaxy. Depending on the assumptions, the number could be 0 or millions. Some scientists even suggest we may not notice alien intelligence because it could be machine-based. Civilizations older than ours might already have merged with technology, existing as planet-sized computer networks or energy beings beyond our comprehension. If alien civilizations are millions of years ahead of us, would we even be able to tell they exist? Or would they look like the very laws of physics themselves? Why haven't we found them yet? This takes us back to the Fermi Paradox. If the universe is full of life, where is everybody? Possible answers include, aliens may exist, but we're too primitive to detect them. They could be deliberately avoiding us, a concept known as the zoo hypothesis. Or maybe civilizations rise and fall so quickly on cosmic timescales that two rarely overlap. Each explanation is unsettling in its own way. The human angle. The search for alien life isn't just about them, it's about us. If we discover life that doesn't look like us, it forces us to rethink what life even means. It challenges religion, philosophy, and our place in the cosmos. And perhaps most importantly, it reminds us that life is resilient, creative, and boundless. So, will we ever find alien life? Probably yes, but it may not look anything like what we expect. Maybe it's carbon-based and familiar. Maybe it's silicon-based, crystalline, or digital. Or maybe it's so different we won't even recognize it at first. The universe is unimaginably vast, and life has had billions of years to experiment. The real question may not be whether life exists, but whether our human minds are ready to understand it when we finally see it. Final hook. And if aliens are already out there, maybe the real reason we haven't found them is because we don't even know what we're looking for.